Okay, I'll make this video as quick as I can. All right, I want to go through the messages coming out of this assessment. And the first big message is that page 1, from question 1 down to question 4, okay, that's worth 30 marks, and that's a C. And by the end of the time you get to the bottom of page 1, you should have got a C or nearly, because there is nothing on this first set of 4 questions that you haven't seen before. So, question 1, part 1, I'm not going to say anything about because most of you could do that one. Part 2, very disappointed in. You have seen a question just like this before. This is page 24 of your core questions booklet. Okay, you have a very similar equation with 2e to the x, 5e to the minus x equaling 7. Okay, the example in the assessment has just got a 3, a 5 and a 16 different numbers. So if you had done that exam questions from the core questions, and if you'd done your dirt properly, you'd used the mark scheme, I don't want you to leave things like this without being able to do them another time. Just as a quick reminder, the trick is to let x equal e to the y, and then work out what e to the minus y is in terms of x, and it's going to turn into a quadratic which you solve. Okay, not forgetting that after you've got solutions for x, you've got to remember that e to the y equals those solutions, so the answers are going to be in exact form in terms of logs. Okay, what I was pleased about is you all did give me, when you had answers, you didn't give me decimals, you did make them exact. See, that's sunk in, that's good. All right, question 2. We've got a quadratic function where we've got to get the range and the inverse. Lots of you did get the range right, but I think you got the range right almost by accident, just by hoping that plugging 3 in would do the trick. For both of these, okay, you need to put the quadratic into completed square form. And this came up on assessment 2. So the assessment you've had back, you know, within a week, I think, of doing this assessment, maybe a little bit earlier, you should have done the dirt and picked up how we find the range of this function and how we find its inverse. Okay, once you've put it into completed square form, once you've got it as f of x equals a bracket squared plus a number, so it's going to be x plus a squared plus b, a will be negative. Okay, then it's a lot like this example from your notes. Here's what the solution to the video looked like. Okay, and what I want you to note on this page is that after swapping for f, we've got y in terms of x. After swapping x and y to get the inverse, okay, when you come to take the square root, it needs a plus or minus, and then we need to select whether it is the plus or whether it is the minus that's necessary. Okay, you may want to rewatch that video again, okay, in order to understand that reasoning. But the message is, it's not okay to have seen questions similar to this before and then get them in a graded assessment and still get it wrong. If that's happening, then your dirt isn't thorough enough. You're not reviewing things you've got wrong in the past and making sure you won't get them wrong again. Remember, if you've got this wrong, if you have this wrong or anything else on the test, put a star next to this question. Okay, keep it in your file and come back to this star and test yourself in a couple of weeks' time. Have you actually got the message? Do you know how to do this type of question now? Okay, finding g f of x. Okay, most of you are okay with that. Very few of you are doing it the wrong way around, which is good. You end up with this being a modulus sign, and inside the modulus you've got a quadratic, so you've got x squared and you've got x's and you've got numbers. Okay, so that wasn't too bad. But then solving a modulus equation, I'm not going to show you an example because you've had trillions of examples of working out the modulus something equals, in this case the modulus of something is going to equal 6. Okay, now we know if this is a v-shaped graph, then drawing the graph is good. In fact, drawing the graph is always good. Here it's a quadratic. Maybe you don't want to sketch it, but in setting up the algebra for the equations, I was really disappointed in how few of you remembered that this turns into 2 equations. So the first equation, whatever is inside this bracket, could equal 6. And the second equation is going to be the minus of whatever is inside the bracket. So all the signs swap, because the modulus can cause that, can't it? So the minus of whatever is in the bracket could be 6. So one equation with a modulus in it turns into 2 equations where the modulus either does nothing at all or changes the signs. And I expect you to be able to set up those 2 equations and solve them. Now there's a twiddly bit at the end of this question because of the 4 solutions you get 2 quadratic equations, you get 4 solutions, but not all of them apply because this means x fed into the function f, and then fed into the function g. And we have a restricted domain on the function of f, so not all of the solutions you get for x will actually be valid. So to get full marks on this question, you actually have to select the valid solutions from the 4 you get. Okay? Question 3 should have been 4 easy marks, okay? If it wasn't, I mean, you just need to go back to the video where we did this. So here we go, type 2 partial fractions. There it is in your notes. That's all you have to do, okay? So if you haven't practiced those enough, put a star next to this question 3. Make sure that this type of question, okay, you've practiced this enough. This is standard, so make sure you can't go wrong. And then question 4, okay, I don't know if you recognize it. This question 4 is straight out of your core notes, your core questions, I should say. So you've been given, if you did the work and you got the mark scheme, you've got a mark scheme for this. So lots of you did do the graph successfully. It goes beyond what's in the notes in that there's a modular sign which makes everything positive. The negative bits become positive, and then the minus sign outside flips everything back below the x-axis. So everything goes positive by the modulus, and then some bits go negative. Okay, you have a work solution to this. Make sure you understand it. And then, I don't know why it says 5, sketch the curve with equation that. This time, there's 2 things going on. There's a multiplication by 2 inside, so that's causing a horizontal stretch. But the modular sign acting inside leaves the x part of the graph unchanged, because these x's are already positive, but the negative values of x, this is completely scrubbed, and we get another copy of the graph, so we get some symmetry. And you've got examples of that in your notes. Here's what that example looked like. So in the first case, we've got the modulus acting outside. You've got to then combine that with making everything negative, so flipping in the x-axis afterwards. That was like the first part of this exam question. And the second part shows what happens when you've got the modulus acting inside, but because of the 2x inside your f of x, you have to combine the effect of the red graph there with the horizontal stretch. So that's this one here. Okay, and then describing your 2 transformations. Most of you had a good fist of that, but look, you need to be clear, still some of you, about when it's inside and when it's outside. When there's an f, it makes it absolutely clear. You should be able to see that both this times 2 and this plus 2 are inside the f. Okay, so starting with f of x, okay, where am I going to put the brackets to turn that into f of 2x? Well, it can only be around the x. Can't put brackets around the whole lot and put a 2 outside. So this will turn into f of, well, we actually have to do the f of x plus 2 first. Okay, and then putting brackets around the x, working inside to get f of 2x plus 2. I have to multiply by 2 inside those brackets. If I ever put brackets around the whole of f of x and multiplied or added 2 outside that, then the 2x plus 2 would not be inside the f. Okay, so maybe some more practice on that to get your thinking straight. So that's that first page. 30 marks we've covered, and I don't think any of them are difficult, particularly not if you've done all the work and you've learned from any mistakes you've made as you've gone along. Okay, now question 5, I have a little bit more sympathy if you didn't get the marks on question 5. We've done this more recently. There isn't an example just like this in the notes, but there are questions like this in the core questions. It's algebraic division. You can't use the remainder or factor theorems when it's a quadratic factor on the bottom, but you can put your quadratic down the side of a grid, 2x squared minus x plus 2. Okay, now we can see the answer. The answer gives us a strong hint that there's just going to be some number of x's at the top, and we won't need the constant column. But in general, okay, if I'm dividing by a quadratic, then I start with x's because I've got x cubes divided by x squareds. Okay, but I might get constants as well. This question is kind of showing me that I won't. But after I fill this column in, I then think very carefully about where I'm up to. So I've got x cubed. I'm going to get an x squared term here. I'm going to get an x cubed term here. Okay, and the next thing to do is to make the x squareds term work. So this number of x squareds, I haven't put the number of x squareds in, there's some number in front of that. Okay, together with some more x squareds has got to give this minus 2x squared. Okay, and it turns out you don't need any. We can see that happening. Okay, but then this column is for the remainder. So we've dealt with the x cubes and the x squareds. Whatever is not already there that I need to make the 16x is going to be part of my remainder, and that's where the b bit comes from. So after you've filled in the first two columns, this is going to be 0, 0 and 0 in this particular case. In general it won't be. So the total number of x's you've got here, you'll have some x's here, you've got no more x's there, and however many more x's you need to make up the 16x is going to be in the remainder column. Once you know what's in the remainder column, you'll be able to suss out what the b bit is going to be. Okay. If you need more help on that, then put a star next to it now, get it sorted out in class, okay, and make sure that if this standard type of question comes up again, you don't get caught out. All right. Question 6 was a really good source of marks for lots of people, so well done if you got full marks on this. Okay. Some of you are trying to do the sign change method without first setting up an f of x, okay, as something that equals 0. And I really want to see the equals 0 on there because that is the key part of it. So the obvious thing to do here is to take away a quarter x and plus 1 from both sides, but there are other ways to do it. Let me show you the mark scheme. So what you're seeing here at the top are 3 different rearrangements, and then I've accepted others as well. These are 3 ways of rearranging the equation to get an f of x that equals 0. But in the right-hand column, you can see every time that an f of x must be defined. If you haven't defined f of x, then it makes no sense to talk about f of 0.5 and f of 1, and this came out in your assessment too. If you haven't set up f of x, you can't get either of the 2 marks for the sign change method. Now you may notice that it seems that the actual sentence they want, okay, looks like it's as simple as saying the change of sign so that therefore alpha is between those 2 limits. Well, maybe you would have got away with that on this particular case, but there have been other mark schemes where it's made it very clear it wants more. So please stick to the sentence I've given you, because then you know you're safe. Okay. The staircase diagram at the bottom, lots of good answers on that. Getting x2 and x3, right, let's get back to the question paper itself. This has been edited from an exam question, all right? So you're being asked to do something here, and you're being asked to do 2 more things here and here. I saw some solutions where people seem to think the sign change method was part 1. The real part 1 has been missed, and then straight on to part 2. So it could be some of you have allowed yourselves to be fooled by the way the question is set out. There are 3 things to do here, not 2. It'll be a shame if you've lost these 2 very easy marks here, because you've simply not fed values into this iteration. Okay, you have examples like that in core questions in notes, so you should have little difficulty putting that right. This last one here, we've just done binomials. Okay, so lots of good answers on this. 1 or 2 issues with this second one. So dealing with the 2 correctly, remember it's a 2-stage process. Okay, I'm not going to do it for you. I'm going to point you in the direction of this video here. So this video has got a 4 at the beginning of the bracket, and on the top line there of the solution you can see the correct way to deal with that 4. Notice that the power of a half ends up applying to the 4, and also end up noticing that although we started with minus 3x, okay, when we take the 4 out we get a 1 minus 3/4 x. So in every bracket from the second line downwards, okay, the 3 minus 3/4 x is what's in the bracket, not an x anymore. So on this one, you've got to deal with the 2 to get a 1 in front of the bracket. This is not going to be a 3x anymore. So when you do your expansion, I don't want to see 3x's in being squared and cubed. Certainly don't want to see x's being squared and cubed. It's whatever this number times x is that appears in every bracket. Okay, should have been 5 easy marks, and quite a few of you did get 5 easy marks. All right, the last one, okay, it says hence. That means use A and B. Now, A is clearly sorted out the top of the fraction for us. And most of you could see that B is vaguely relevant to the bottom. One of you even wrote down, oh, I've noticed that there's been a change of sign. Okay, so I need to muck up my expansion for part B and use it. The reason why there's been a sign change is that this is on the bottom. Okay, if you did expand the top of this and the bottom of this and get a whole load of x of powers on the top and a whole load of x powers on the bottom, there's nothing you can do with it. You'd have a horrendous, infinitely big algebraic division to do. All right, an expansion over an expansion is no use. An expansion times an expansion is some use. So what you have to see is that this expands into, or can be rewritten as, a bracket to the power of a quarter, and then the bracket on the bottom with a power of 3 on it is a bracket to the power of -3. And lo and behold, you've got your expansion to part A and your expansion to part B just being multiplied together. And you only need to keep multiplying until you get up to the terms in x squared. This expansion only goes up to x squared. This one only goes up to x squared. So although when you multiply your answer to A by your answer to B, you'll get some higher powers if you do everything, you need to ignore them because they're not wanted, because we only want to go as far as x squared, and they're not even correct, because to get this expansion correct up to x cubed, you would have needed to have gone further with both of the earlier expansions. Okay, so you just expand what you've got from A times what you've got in B up to the terms in x squared. Any higher terms you just ignore. Okay, that was question 7. And lastly, question 8 is just another algebraic division, but now we're dividing by a quadratic, but it hasn't got an x bit, so you may find it clearer. I would strongly recommend, actually, you say that you're dividing by x squared, no x, and by 2. Okay, so we need to put across the top whatever we need to make this. So we need to decide how many. We're starting with x cubed, so I'm going to have some number of x's here. I fill in this column, and then I look at the x terms here. Sorry, I should say x squared terms. This is going to be an x squared term. And I need some more x squared terms here to give me the correct number of x squareds, which is 4x squared. If you miss out this, then it may make you stop considering x squareds at all. So you fill in your constant, whatever number that is, you fill in 3 values here. Okay, and then this bit here is called the quotient. So you might want to look back at your notes. So there's an example from your notes, and you can see the quotient comes from the polynomial across the top of the grid, the one you need to, in this case, multiply the x plus 2 by, and then the remainder is what was needed to make, in this case, just the numbers work out at the end. Now, the difference between this and the one on the assessment is that the polynomial down the side here was just linear, it was x plus 2, whereas in the assessment it was a quadratic expression, x squared plus no x plus 2, and that means that the remainder, there are going to be in this last column 2 things, both x's and numbers, that haven't come right yet. So your remainder will be a linear expression, some number of x's plus some number. Okay. Now there wasn't an example exactly like this one in the notes, but there were examples like this in the core questions, and there are more examples we can find for you to practice on. So go through the whole test now, put stars on all of the questions that you didn't get right, and do something about it. So the same things will come up again. A lot of these are very standard types of questions. You don't want to be caught out again. What matters isn't what grade you got this time round, it's what you do from now on that means that the grade at the end of the course will be the grade that you want or you need. All of you have passed this test. A lot of you can pass it better than you passed it first time round. So it's what you do now that will make the difference. So get stuck in and do some dirt.